what we're gonna do is we're gonna figure out how many of each element are inside this molecule. Okay, so if you guys know how to do this, you guys can just ignore me for a little bit and finish it up. But just make sure you're following along. So let's start with this molecule right here. The first element that I have is aluminum. It's Al. Okay, and we know that because the capital letters tell us what the elements are. So if you go to the periodic table, you'll see that Al is aluminum. Okay, so let's write that down on our paper. We have Al. Okay, so the first element in this molecule is Al. Okay, now we want to know how many Als there are. So how many Als do you think there are in this molecule? 2, yeah, it's just a number right behind it. So there are 2 aluminums. Okay, so I'm just going to put times 2 to represent that there's 2 of them. Okay, the next element is going to be S, which is sulfur, and we know that because of the capital letter. So if we go to the periodic table, you'll see that the capital letter S is sulfur. So we're going to write sulfur. Okay, so inside the parentheses, how many S's are in the parentheses? Okay, so in the parentheses. 1, yeah, there's no number, so it's 1. But since there's a number 3 behind it, you multiply it by 3, the number on the outside. So there's going to be 3 sulfurs, okay? Pretty simple. And then last but not least, we have 4 oxygens in there, and there's a 3 on the outside. So how many oxygens do we have total? 12, yeah, because we need to do 4 times 3, yeah. No, you chilling. Okay, so just multiply what's on the inside by the number on the outside, okay? Okay, just make sure that you guys are comfortable counting these atoms because it's kind of the basis for what we're doing today. So this is just a review problem. Now we're going to get into the actual topic for today. But before we do, any questions on how we got those numbers? That's good? Okay, let's move on to what we're learning today. So before we start, let's do a quick pop quiz to see if you guys know some basic info. So if I have blank of something, how many do I have? If I have a dozen. 12. Yeah, 12. Dozen is going to be 12. What's the number for 1 pair? 2. And a trio? 3. Good. So these words basically tell you how many of something you have, right? Okay, so a dozen is 12, a pair is 2, etc., etc. You guys are familiar with this. Now, in chemistry, there is a term that we use to count stuff, and it's called a mole. So just make sure you guys write this down somewhere, 1 mole. I'll tell you guys what number that is in a second. It's the same spelling as that ugly little animal that lives in the ground, right? A mole, okay? But a mole in chemistry is how we count atoms and molecules, okay? Just like how eggs, you count them in dozens, shoes, you count them in pairs. We count atoms and molecules in moles. Now, the number for mole is very, very big, okay? So I'm going to show you guys the number for mole. And so this is the number for a mole. Make sure you guys write this down somewhere in your notes. You guys don't need to write down this big number right here, but the number for a mole is this right here. So if I have 1 mole of something, I have 6.02 times 10 to the 23rd, which is the same as this big number down here. And the number is, hold up, million, billion, trillion, quadrillion, quintillion, hexillion, it's 602 heptillion. Okay, you guys probably have never even heard that number before, right? Because it's such a big number. Okay, so atoms are so small that we can't even count them a million at a time, a trillion at a time. We have to count them 602 heptillion at a time, okay? So just to kind of help you guys visualize, if you have a dozen donuts, you have 12 donuts. If you have a mole of donuts, you have 602 heptillion donuts. If you have a pair of shoes, you got 2 shoes. If you have a mole of shoes, you have 602 heptillion shoes, okay? Yeah, it's a lot of shoes, I know. I wish I had that many shoes. Huh? A what? A trio? A trio would be 3. If you have 3 of something. Yeah, so if you have 3 of something, it's trio. If you have a mole of something, it's this many. Okay, now this number is called Avogadro's number. I put a picture of an avocado because they kind of sound similar. But we use this number to count atoms because they are so small. Okay, so make sure you guys write this right here. This is the definition that we're gonna do all our problems with. It's gonna be molar mass. So today we're gonna be learning how to calculate something called molar mass. Okay, we're gonna be counting or calculating something called molar mass. Okay, and the molar mass is basically the mass of 1 mole. So if I have 1 mole of something, how much it weighs is called the molar mass. Okay. Now, we can find the molar mass for an element by looking at the number on the bottom of the box in the periodic table. So if you guys go to the box for each element on the periodic table, the number on the bottom is going to tell you how much 1 mole of that element weighs. And so we have xenon right here. And xenon, if I have 1 mole of xenon, it's going to weigh 131.293 grams. Okay, so 131.293 grams is equal to 1 mole of xenon. Okay, that's what a molar mass is. And so when you're finding molar mass in your problems today, the unit of measurement you want to use is grams per mole. We can write it as grams/mole. This is the unit of measurement. Okay, so these are the units. So make sure that when you guys are doing your problems, you don't just write the number, you always write grams per mole behind it. And this will be important because later we're going to be using this to do dimensional analysis. Okay, so we're going to do a couple practice problems and then we'll finish off today by doing dimensional analysis with molar mass. Okay. Okay, so let's do a practice problem together and then we will move on to some harder problems, okay? So we're gonna be taking a look at phosphorus. So I want you guys to go to the periodic table and look for phosphorus. It's gonna be the number on the far right. And I want you on your paper to write down the molar mass of phosphorus. Take about 30 seconds to do that. Make sure you guys write the number and that you write the unit of measurement. Okay, so take about 30 seconds. Write the molar mass of phosphorus. Okay, it's on the right side of your periodic table. Yeah, write it on your paper. All right, guys, let's reconvene. Let's go over it together. So if you guys take a look at the periodic table, okay, you're going to find phosphorus right here. Okay, phosphorus is P. And what's the molar mass of phosphorus? 30.97. No, it's a solid at room temperature. Okay, so 30.97. Okay, we're going to write 30.97. And what are the units of measurement? Yeah, G/moles, grams per mole. So you would have to write this for the molar mass of phosphorus. Okay, pretty simple, right? That's it. Okay, but obviously I'm not going to make it that easy for you guys. Okay, so we looked at how to find the molar mass of one element, but we can also find the molar mass of molecules. So when elements stick together to make a molecule. So here I have the chemical formula for meth, and yes, it is that meth, methamphetamine, the drug. And so this is the chemical formula for meth.
So if I combine all those, I will make meth.
Yes, but you don't know how to do that.
Yeah, I don't.
You don't. Wink, wink. Okay. I will never teach you how to make meth. Okay, so let's take a look at the formula. Let's break down what elements are inside of meth. Okay, so how many carbons are inside of meth? 10. Okay, so let's write that down on our paper. There's 10 carbons. Yeah, 15 hydrogens. And lastly, how many nitrogens do we have? 1. Good. So let's just jot this down on our paper because we're going to need to know how many of each element we have in order to find the molar mass of the combined molecule. Okay. So basically what we're going to do is we're going to figure out how much do all the carbons weigh, how much do all the hydrogens weigh, how much do all the nitrogens weigh, and then if we put it together, we can find out how much a mole of meth weighs. Okay, so let's go to the periodic table. I want you guys to find carbon on the periodic table. What's the molar mass of carbon? Yeah, 12.01. So on your paper, you're just going to write that carbon is 12.01. And since I have 10 of them, I'm just going to multiply it by 10. Okay. So again, you're going to need your calculators today. So what we're going to do is we're just going to do 12.01 times 10. So all of the carbons inside of meth, it's going to have a mass of 120.1 grams per mole. Okay, super smart. Okay, let's go to hydrogen now. So if we look for hydrogen on the periodic table, we'll go all the way to the left. What's the molar mass of hydrogen? Yeah, 1.01. So we're just going to write hydrogen is 1.01 times 15, and that's going to give us a value of 15.15. Yeah, super easy. So all of the carbons inside of meth, they're going to have a mass of 120.1. All of the hydrogens are going to have a mass of 15.15. And then lastly, there's one nitrogen. So we can just go on the periodic table and look at nitrogen. Yeah, exactly. 14.01. So nitrogen and it's times 1. So we don't have to do the math for that. We can just put 14.01. Okay, so we found out how much all of the individual components weigh. Now what we have to do is just put them together. So we're just going to go on our calculators real quick. We're going to do 120.1 plus 15.15 plus 14.01, and that'll give us the molar mass of meth. So the molar mass of meth is 149.26, and the unit of measurement is grams per mole.
Wait, that's how much it weighs?
So if you have a mole of meth, that's how much it weighs. So if I had 602 heptillion molecules of meth, it's going to weigh that much. Now, if you guys know anything about the drug game, that's a lot of meth. That is a lot. That's like tens of thousands of dollars. If you have 150 grams of it, you will definitely go to jail for a long time for that. For possession even. Yeah. Okay. But since I'm recording this lecture, I just want to make a disclaimer. I do not support drugs. I do not support meth. I have never and will never make meth, okay? And I will not teach you how to make meth. Guys, I am not going to make meth. I'm not going to jail. Do you see me? You think I'll survive in jail? I won't survive in jail, guys. My jumps will not save me from jail. Okay, let's have you guys try one on your own, and then we'll go on to the next type of problem. So what I want you guys to do is work with the person next to you. I want you guys to find the molar mass of CuSO4. So take 2 minutes to do that. We'll go over it together and move on to the next type of problem. Alrighty, guys, let's find the molar mass of CuSO4. So let's look at Cu. Cu is the first element. It's copper. What's the molar mass of copper? 63.55. So we're going to write that Cu is 63.55. We have sulfur. What's the molar mass of sulfur? Yeah, 32.07. It's going to be right here. So we're going to write that sulfur is 32.07. Now, we know that oxygen is 16 each, right? But since there's 4 of them, what we have to do is multiply it by 4. Yeah, exactly. And that's going to give us 64. Okay, so we're going to add them all up and see what we get. Man, you guys are too fast. So 63.55, 32.07 plus 64, 159.62. Okay, and make sure that you guys write grams per mole. Okay. Yeah, don't forget the unit of measurement. So on your assignments and your labs and stuff going forward, if you don't write grams per mole, you will not get credit for that answer. You have to give me a unit of measurement, okay? Okay, so I'm not gonna keep it that easy for you guys. So at the end of your assignment, we are going to combine this with dimensional analysis. So the fraction, I know. It's how much I love you though. This is my gift to you. Merry Christmas. Okay, so in dimensional analysis, what you want to do is you always want to figure out what your given or starting number is, and you want to figure out what the ending number is. Okay, what you want to end up with. So write that down on your paper. You guys don't need to copy the question, just write down the given and the end because that's what we're going to use to figure out this problem. Okay, so the given is always going to be a number. So if you guys take a look at this problem, what's your starting number?
0.25.
Exactly, 0.25. However, remember, you can never write just the number by itself. So the unit of measurement for this is moles of CaCl2. Okay, so that entire thing is your starting number. You're starting with 0.25 moles of CaCl2. Okay? All right, now we need to figure out what we're looking for. So the question is asking, what is the mass? So I'm trying to find mass. So if you guys ever see mass in chemistry, you're looking for grams. Okay, so make sure you jot that down as your ending point. You're starting with 0.25 moles. You want to find grams of that chemical, okay? All right, so from here, we know how to do this. All we need to do is set up a fraction. So we're going to do 0.25 moles of CaCl2, and then we're going to set up a fraction. Okay, I told you guys, you're never going to escape this for the rest of the year. We're just going to be doing this over and over and over again in a million of different types of problems. Okay? All righty, guys. So let's get into it. Okay, so we set up our fraction, and now let's figure out what to put on the fraction. So I want to get rid of moles. So if I want to get rid of moles, should I put it on the top or the bottom? The bottom, yeah, that way it can cancel out. So moles of CaCl2 goes on the bottom. And then I'm looking for grams, so I'm going to put grams of CaCl2 on the top. And then from there, we can solve it out. All we need to do is plug in the numbers, okay? So we're almost done. Now, if you guys notice, on this fraction, we have grams and moles, right? So I want you guys to write this down because it'll be very helpful for you throughout, I guess, the entire year. But if you guys ever see grams and moles on the same fraction, so if you guys ever see grams and moles on the same fraction, you are going to get your number from the molar mass. Okay, so if your fraction ever has this, if it has grams on the top, moles on the bottom, or if you have moles on the top, grams on the bottom, you are going to get the numbers from the molar mass. Okay, so here we need to find the molar mass of CaCl2. That's where we're going to get the numbers. Okay, so let's look at CaCl2 on the periodic table. First element is Ca. So what's the molar mass of Ca? Far left.
40.08.
Yeah, 40.08. Good. So it's going to be 40.08. So calcium has a molar mass of 40.08. Now we have chlorine. So we're going to look at chlorine on the periodic table. What's the molar mass of chlorine?
35.45.
Yeah, 35.45. However, how many chlorines do I have? 2. So what we have to do is we need to take the molar mass of chlorine, 35.45, and multiply it by 2. And that's going to give us 70.9. Good. So if I want the molar mass, all I need to do is add them together. So I'm going to take 40.08 plus 70.9, and the molar mass of CaCl2 is going to be 110.98. But what are the units of measurement?
Grams per mole.
Exactly, grams per mole. And that's very important because that's going to show us where to put the numbers on the fraction. Okay? All right, before we solve the problem, any questions on any of the steps so far? Guys good? Okay. So on the top, we have grams. So let's look at the molar mass. This is where we're going to get the numbers. Okay, what number is grams next to? Not moles, number. Yeah, it's next to 110. So whenever you guys have the molar mass, the number that you add up will always go next to the grams, okay? Make sure you guys remember that. The number that you added up will always go next to grams because if you guys notice, it's next to grams, right? So it's going to go next to grams. So the number you add up from the periodic table, we will always go next to grams. And if you go to moles, remember, this is grams per mole. What number does per mean? 1. So you'll always have 1 next to moles, okay? So it doesn't matter if moles is on top or the bottom. You always put 1 next to moles, and the number you added up always goes next to grams, okay? And then from there, we just solve. Moles cancels out. And then we just need to multiply the top, divide the bottom. So 0.25 times the top, 110.98. That's going to give us a final answer of 27.745 grams of CaCl2. And that's it. That's how you do dimensional analysis with molar mass. Now, what we're going to do next time is we're going to combine this with balancing. And so, yeah, I know it's going to be 3 fractions at least, but I'll take it easy on you guys and give you 1 fraction for today. Yeah, Merry Christmas. I'm a terrible gift giver, huh? Okay, so we'll do one more example together and I'll have you guys start your assignment. That way you guys have some examples to look back at if you guys get stuck or you need to review this info. What's that? No, there's a chemical I want to talk about right now. Okay, so we're gonna do an example with my favorite chemical in the world. It's not meth. Somebody said it was meth earlier, but my favorite chemical is caffeine. Okay, so my morning coffee usually has about 0.5 grams of what I think is one of God's greatest gifts to mankind, which is caffeine, because it's straight up a stimulant with no negative side effects. The only side effect is dehydration and diarrhea. It does not stunt your growth. Okay. Now, what you're gonna do is you're gonna calculate how many moles of caffeine are inside my morning coffee. And yes, I have actually tested this. There's about 0.5 gram. Okay. So take about 3 minutes. You can work with the person next to you. I want you to calculate how much caffeine, how many moles of caffeine are in my coffee. Okay. And then we'll go over it together and I'll start you guys on your assignment. Okay. Take about 3 minutes to do that. Let's get started, guys. So first thing we want to do is we want to find the molar mass of caffeine. Okay. So, oh, what is this? Okay. So if we take a look at caffeine, how many carbons do we have? 8. We have 8 carbons. Now carbon, each of them have a molar mass of 12.01. So what we're going to do is we're going to get our calculator and do 12.01 times 8. That's going to give us a total molar mass of 96.08 for all the carbons. Okay. There's 10 hydrogens. And so hydrogen is 1.01. So it's going to be 10.1 for all the hydrogens. Okay. So far, so good? Okay, there's 4 nitrogens. Each nitrogen is about 14, and there's 4 of them, so that's going to give us a molar mass of 56. Okay, might be off. 56.04. Okay, and then we have oxygen, which is 16 each, and there's 2 of them, so there's 32. Okay, so all we did was go to the periodic table, look at the elements, just multiply by the number in the molecule. All right, so the grand total for the molar mass of caffeine is 96.08 plus 10.1 plus 56.04 plus 32. 194.22. Okay, so caffeine's molar mass is 194.22 grams per mole. All right. Okay. Now let's do the dimensional analysis. We're going to start off by writing down our starting number, which is 0.5 grams, right? 0.5 grams. And I'm going to write caffeine just to specify what chemical we're talking about. Okay, we're going to set up a fraction. Since I want to get rid of grams, where should I put grams on the fraction? Bottom, good. And what should I put on the top? Moles. Yeah, because it's asking how many moles. Okay, we're going to plug in our numbers. Now, let's see if you guys remember. What number goes next to moles? 1. It's always 1. Mole always has 1 next to it. Okay, and so the number we put on the bottom is 194.22 because, again, 194.22 is next to grams. And from here, the grams can cancel, and all we have left is moles. So we just do top divided by bottom, 0.5 divided by 194.22, and we will get 0.00257. Okay, so if you guys were able to get that on your own, you should be in pretty good shape for today. All right, and that's pretty much it. Any questions on this problem? Hopefully not too bad. What was that? Yeah, I'm gonna have this up here. All right. So this lecture was recorded, so if you guys need to see it, it will be on Canvas, so you guys can check it out. Other than that, you guys can start on your assignment. Let me know if you have any questions or if you want to check your answers.